I thought I'd do a video about the general diagnostic process or how to solve problems. Now, the reason that I'm doing this is that I see lots of posts on Facebook of people saying, help, my car doesn't start, or I've got some problem. They don't give enough information to be able to solve the problem, which makes sense because if they had all the information to solve the problem, they would have already solved the problem. And in some cases, some people say, look, you've just got to diagnose it, which is true, but not helpful. I've heard the term, just we'll roll the diagnostic dice and just see what the problem is. But in a lot of cases, you actually get a whole lot of suggestions which are completely useless, like oh, check the crank angle sensor, check you've got power to the coils, check you've got fuel, and things like that, which, yes, any of those might be the problem, but there's not really enough information to say what the problem is from what the person has posted. So in a lot of cases, an experienced tuner or someone like that will go through this process in their head, just out of initiative or nous or experience or whatever you want to call it. But I'm going to teach you the method if you don't have all that experience in nous, which always works. It doesn't mean it'll be fast, doesn't mean it'll be easy or cheap, but it does always work. So I'm going to pick as an example, my car doesn't start, because yeah, that's a thing that probably a lot of people could relate to. What we're going to do is we're going to follow the scientific method. And the reason we're going to do that is that the actual thing that we're trying to solve here is we're trying to diagnose the problem. Once you've actually diagnosed the problem, normally the solution is pretty straightforward. But the trick is to actually work out what the problem is in the first place. So the scientific method is how we learn about the world. If we want to do it in a way which is repeatable and works, and we all learnt this at school, but basically you form a hypothesis, which is an idea. It might be true, it might not be true, we don't know yet. Then you can design an experiment. And that will tell you whether the hypothesis is, well, ideally that will tell you if the hypothesis is false. You can't always design an experiment to prove that it's true, but you can normally design an experiment to rule it out. And then you can then carry out the experiment, perform the experiment, and then you can get a conclusion from that. Now, I'm not saying you have to write all this out like you're in high school, but these are the steps that you need to go through if you want to avoid wasting time with things that aren't relevant and confusing yourself. So, take the my car doesn't start example. The first step is to generate all the hypotheses that would explain why the car doesn't start. Now you might think, how can we ever do that? Because there are hundreds of them. It could be the ECU is not plugged in the whole way. I've got a bad map. I've got bad fuel. My fuel pump's not working. I've got a loose wire somewhere. I've got a blown fuse somewhere. There must be hundreds of things that could cause the car not to start. And that's true. But the trick is to form a certain number of hypotheses that can divide down the problem into different areas that you can test easily. So you don't want to spend a whole lot of time on tinfoil hat conspiracy theory hypotheses, which are very unlikely to be true. And you don't want to spend time on things which are going to be very difficult to test as well. So if you can't think up what are the what's a exhaustive set of hypotheses that explain why it doesn't start, you can do it the opposite way around, which is, what does a car need to start? And my father told me when I was a lot younger that an engine only needs fuel, spark, and compression. If you've got all those things, then it'll start. Now, probably he'd be a bit more nuanced about that if I asked him now, because you've got to have the right amount of fuel, you've got to have the spark at the right time, and it's got to be a strong enough spark. And you've also got to have air as well. You've got to have enough air for the engine to make enough torque to run. So basically, we're going to, if it doesn't start, then we're missing one of these three things. Now, compression you can test easily enough with a compression gauge. You can normally hear it as well. Like if an engine's low on compression, or it's someone's installed the cams the wrong way or something like that, the engine just won't sound right when it's cranking. So normally that one's pretty easy to test. So fuel and spark are the other two ones. So we can test that one if we want to, but I think that's also less likely than these two to be the problem. So fuel and spark are the other two. Now, how would we test if the fuel is a problem or the spark is a problem? I'm going to pick fuel first of all. That's really easy. All you need to do is try and fire it up on Aerostart or brake cleaner or start your bastard or whatever your favourite thing that burns easily is. And if it fires up on all cylinders on that, then you know that your spark's fine, it's at the right time, and you've got good compression, and you only have a fuel problem. And then you can start to divide down what fuel problem might you have. Could it be bad fuel pressure? Or could it be bad injectors? Or could it be the bad injector signal? And you can test that. For example, if you've got a bad injector signal, you can test it with a Noid light, but only if you know what you're looking for. You could also actually manually pulse the injector by pulling one side of it to ground. You could put a screwdriver on the injector while cranking it to see if you can hear it tick. Fuel pressure, you can measure that with a gauge fairly easily. If you've got a fuel pressure problem, then it could be a problem with your pump, or it could be a problem with your reg, or your filter, or whatever. But regardless, the most efficient way to do it is to, rather than start by saying my car doesn't start, let's check the fuel pump. Start with my car doesn't start. What sort of category is the problem? And then you can break it down into smaller steps. That way you can arrive at the real answer a lot more quickly, rather than chasing a whole bunch of minor things and swapping bits out and getting more frustrated. Now, I might just follow this example through for the sake of argument. If you don't have spark, then it could be an ignition problem. But in an EFI system, that could also mean that the ECU doesn't have a good trigger from the crank or the cam angle sensor. One of the reasons I like aftermarket ECUs is the amount of diagnostics that you've got available. So you can see if you've got full sync. If you've got full sync and you don't have spark, or you don't have spark, then you can look at the signal from the ECU. On the Nexus ECUs, you can look at the ignition output voltage on the built-in scope, and then you can see that pulsing. If you're driving the ignition coils off a 25 amp output on an Nexus ECU, you can look at the current on that channel as well, to see if the current's rising up like that when you've got your ignition pulse there. So you can do all those sorts of things to see if the coil is actually connected. Of course, you can check it with a timing light. You can take a lead off and just see if it'll jump a gap. One thing I'll say with regard to checking for spark or checking an injector with a Noid light is that unless you know what a good thing looks like, don't do it, because people will say, my spark looks weak. Your spark is always going to look weak at cranking, because people have got this idea that it's this brilliant blue thing because they expect it to be like an arc welder or something like that. So only if you know what a good one looks like is that a fair comparison. Being weaker than you expected doesn't actually contain any information. So yeah, the main point is that each of these you want it to be easy to test. And the more tools you've got to be able to test, the easier it is, obviously. But you really want to work out, you really want to subdivide the problem rather than looking at individual parts that might be the problem first of all. And then, if you're going to try to get help from someone, then make sure you've got all the information in there, like include a log file. In NSP, the PC log files include every single channel, which means that if someone wants to go and look at the trigger synchronization status, something like that, that'll be in there. So I'd always recommend doing that. Hopefully this is helpful. Have fun.